Today we're going to focus on our normal model. So in the last section we talked about the difference between discrete and continuous probability distributions. We said that discrete probability distributions were pretty nice and easy because we were only dealing with whole numbers. They were things that could be counted. We could put them in nice little tables or charts or pretty simple graphs. Again, in this section, as we finished up in the previous section, we're looking at continuous variables. So we're looking at our continuous probability distributions. And so we're going to be focusing on finding the area under a curve. As far as this course goes, we're going to focus on one specific type of curve. It's something that some of the stuff in this section we've already talked about back in chapter 3. So what we're going to be using is we're going to be using our normal model. So the normal model is what we're going to focus on in this section, and it is the most widely used probability model for continuous variables. As we're doing these, we're going to use what we're going to call and refer to as the normal curve. The normal curve is something that we have already seen this semester. Our normal curve is a nice unimodal symmetric distribution. So remember that symmetric distributions are histograms whose left and right sides are roughly mirror images, and unimodal means that it has exactly one mode. Right? There's only one mound in there. And we saw these and we used these previously in chapter 3 to do some different types of things. Our normal curve is also sometimes called a Gaussian curve, or more often than not, it's called and just commonly referred to as a bell curve. Right? So our normal curve is a bell curve. It's something that is unimodal and symmetric. So if we look at these two images that are down at the bottom, right, very rarely, again, are our probability distributions perfect. Right? These are models, so they closely fit. So if we look at these two histograms at the bottom, they're not perfectly symmetric, but they're close enough. Right? So the idea with using the word model is, again, it may not be absolutely 100% perfect, but it's good enough to give us a pretty good idea. Right? In both of these histograms at the bottom, right, we're unimodal, we're symmetric, and we are bell-shaped. Right? We talked a lot about this before when we were finding z-scores and talking about our empirical rule, which is going to be a big part of this chapter then as well. All right, so going back to chapter 3, when we talked about our empirical rule and our z-scores, and we did a bunch of stuff with that, we talked, that's where we first introduced our mean and our standard deviation. So we're going to have a mean of our probability distributions, and we're also going to have a standard deviation of our probability distributions as well. Unlike chapter 3 where we focused on finding these, in most cases these are going to be information that's given to us. The big difference in this chapter compared to chapter 3 is notation. So notice that in this chapter, right, our mean is going to be represented by a Greek letter, kind of this weird looking M thing that we refer to as mu. Right? It's still our center, it's still our balancing point of our distribution. Our standard deviation, instead of using the letter S, we're going to use a Greek letter sigma. Right? So it's this weird kind of almost little O looking thing with a tail. Right? Our standard deviation still measures a spread just like it did back in chapter 3. As far as our notation goes, we're going to see, again, we're not going to focus so much on finding our mean and our standard deviation, but using our standard deviation and our mean. So a lot of times we're going to be given stuff in a notation that looks like this here. We're going to have the letter N for the word normal, right? Thinking our normal model, our normal curve. And then we're going to be given our mean, again, which is this mu, this Greek letter mu, and then we're going to be given our standard deviation, which is represented by this sigma. Right? So again, this idea is very, very similar to chapter 3. One way to kind of compare these, I'm just going to draw a little table right here. Right? So mean and standard deviation. Right, in chapter 3, when we were thinking about our mean and our standard deviation, we used X bar for our mean and we used the letter S for our standard deviation. Now when we're thinking about our probability distributions, again, instead of seeing this X bar, we're going to see the mu. And instead of seeing the letter S for standard deviation, we are going to see a sigma for standard deviation. Looking at these couple of pictures at the bottom, right here we're going to kind of talk about, be introduced to our notation a little bit and compare our mean and our standard deviation. So looking at this first one that we have here, right, looking at this image here, notice that our distributions are both unimodal and symmetric, right? However, they are much different in height, right? The taller one has a smaller standard deviation, right? The other one has a larger standard deviation. The smaller the standard deviation, the taller and skinnier our distribution is going to be. The larger our standard deviation is, the more kind of spread out our distribution is going to be. If we look at these though and we compare these, right, if we were to draw a dotted line down the middle, notice that it goes through the middle of both of these. So in that case, in this image, both of our distributions have the same mean, but they have different standard deviations. Right? So the mean is our middle, it's the center of our distribution. And our standard deviation tells us how spread out these are going to be. Now if we look at this other image underneath, right here, right, we have different centers for our different distributions, right? But they are the same height. So in this case, both distributions here have the same standard deviation because they have the same height, but they have different means. They have different centers, right? So as we're looking at these and we're comparing these images to one another, again, if you're seeing the word mean, think about center. If you're seeing the word standard deviation, then we're thinking about how tall or short our curve is, right? How is it spread out? Is it tall and narrow, or is it short and wide? In this particular second example, I've also included the notation here. So we can use our notation to describe these. So the n again stands for our normal curve. Right? The first number is our mean, and then the last number is our standard deviation, excuse me. So for instance, if we look at the men's curve, the mean is 69, the standard deviation is 3. If we look at the women's curve, the mean is 64, the standard deviation is 3. Right? So we're going to start seeing this notation as we continue to go through a lot of other examples in this section. All right, as I've already mentioned, right, we talked a lot about our empirical rule back in chapter 3 when we were talking about our mean and our standard deviation. So this next thing that we see has not changed at all. Right? This is the same exact stuff that we used back in chapter 3. So our empirical rule gives us information about 1 to 3 standard deviations away from the mean. Remember, about 68% of our data or observations are going to be within 1 standard deviation, about 95% within 2, 99.7% within 3. And also remember that we use the word unusual, right, to tell us if something was more than 2 standard deviations away from the mean. All right, so looking underneath here, we have a couple of images. Right? So as we're looking at these images, same exact things that we saw back in chapter 3. Right? So shows kind of our breakdown of our different standard deviations, also shows individual percentages for some of these different ones. Again, all of this relates back to the same exact empirical rule that we talked about in chapter 3. So thinking about our empirical rule, Right, we just want to review a little bit here for this last example. Right, so roughly what percent of the z-scores are between -1 and +1? Remember that should be 68%. Between -2 and +2 is 95%. Between -3 and +3 is 99.7%, right? Or almost all of our observations. Right? Roughly what percent of our z-scores are between 1 and 2? If we look up to our picture here, between 1 and 2 would be this little portion here. And I know it's kind of difficult to see on this one here, but there is a little 13.5% written right there. Okay. So our answer to D down here is 13.5%. Roughly what percent of z-scores are greater than 0? 0 is the middle. Right? 0 is the middle, 0 is our mean. Since it's exactly in the center, right, that means that 50% are above and 50% are below 0. Right? As we're looking at these percentages, tying this back into our continuous variables that we're talking about, thinking about our probability distributions, these percentages are all related to the area under the curve. So I'm just going to make a little note here that remember percent is the area under the curve. So again, going back up and looking at this image, 68% is between one standard deviation, right? 34% on each side of our mean. Right? The area under the curve in this particular case would be 0.68 out of 1. Right? So all of these different percentages that we've looked at for our empirical rule are connected to the idea of area. So what we're going to spend our time doing in this chapter is we are going to talk and figure out just some different ways to find our normal probabilities. So as we are going through and doing these, there's going to be 3 major steps that we're going to go through. We're going to start with a picture of a curve. And our picture of our curve is always going to be a nice unimodal symmetric curve that looks like our empirical rule pictures. Now the difference is, instead of just focusing on numbers that are exactly at our standard deviations, we want to be able to find other areas as well. So we're going to sketch out a normal curve. We're going to label it just like we did back in chapter 3. We're going to use our standard deviation to move to the left and the right and get some different numbers to label our horizontal axis. Once we label our horizontal axis for our z-score, right, for our normal curve, then we're going to find our z-score. Right? And our formula for z, again, looks very, very similar to what we used before. Z equals x minus mu over sigma. We've just replaced our x bar and our s with our new notation. So it's still our observed value first, right, minus our mean up on the top. It's just mean is now mu. And then we're going to divide it by our standard deviation. So our standard deviation is at sigma in the bottom. Then based on what type of probability that we're looking for, we're going to use a table. So in these cases, when you're going through homework in MyMathLab, there are going to be cases that actually have a table kind of embedded in the question that it'll bring up. I will also post a table, not a blank table, but a table that you can print off if you want to use as you're going through and working through the homework. And as we go through this section, we're going to talk a lot about this table. So we will talk about this step 3 in a few minutes. But before we do that, I want to focus on our first step. So our first step, we're going to focus on and do some practice sketching our normal curve. So we're going to start with a normal curve. In this case, I have them printed in here already, so we don't actually have to sketch them. We're just going to label them and go through and answer the question that way. Again, our mean is always going to be in the center. We're going to use our standard deviation to move to the left and the right. And then what we're going to do in these problems is we're going to actually shade in our picture, and then we're going to use that picture in another example in the chapter to actually answer some of these questions. So example 2, again, we're going to look at sketching some normal curves. So reading through the line of our problem here, the normal model N64-3 gives a good approximation of adult women's height in inches in the United States. Suppose we were to select an adult woman from the United States at random and record her height. Draw a sketch of the normal curve to find each probability in the question below. Okay. So before we go any further, let's look back up to our notation that's up here at the top. Remember, our N stands for our normal model. Our 64, our first number, is our mean, and then that 3, that second number, is our standard deviation. So looking at this curve, I'm going to start by labeling this. So my mean is 64, so that's going to be the number that goes in the very center. Right, and then my standard deviation is 3. So as I move to the left and right, I'm going to add and subtract 3 appropriately. Right, so to move to the right, I'm going to take 64 and add 3 to get 67, add 3 again to get 70, add 3 again to get 73. As I move to the left, right, I'm going to go back to my 64, I'm going to subtract 3 to get 61, subtract 3 again to get 58, subtract 3 again to get 55. Right? And actually all 3 of these examples are using the same normal model. So if you want to, you can fill them all in now, or we can fill them in as we go, right? But they're all going to be using the exact same labeling here. Right? So again, as we're doing these, this one in particular, I used kind of nice numbers to work out. If you do have decimals or things like that, do be forewarned that you will most definitely want a calculator handy as you're going through these problems, not just for this reason. All right, so A says, what is the probability of randomly selecting a woman taller than 62 inches? Right. So there's a little note here. We're not going to worry too much about taller or taller than or equal to. So for the most part, if we're thinking about these in symbols, all of these problems that we're going through, we're using greater than or equal to or less than or equal to. So they could possibly be equal to those values, but that's not necessarily our main concern. Okay, so what is the probability of randomly selecting a woman taller than 62 inches? So the first thing I'm going to do is I'm going to go to my horizontal axis and find approximately where I think 62 is going to be. Right? And then I'm going to extend a vertical line up in my curve from that 62. Right. Then we need to decide which side of our curve do we want to shade. Right? Taller than 62 means we want to shade our area to the right. Right? So in this case, we would take our curve and we would shade the area to the right of that value. Right. For B, same curve. Again, I've used the same labels, right, using our mean and our standard deviation. Right, so now we're asked, what is the probability of randomly selecting a woman between 62 and 67 inches tall? Right, so 62, again, is right about there. 67 is there. And we are going to shade that area right in the middle. Right, and then C, again, using our same labeling along our horizontal axis. What is the probability of randomly selecting a woman less than 62 inches tall? Right, so here we draw our line for 62. Less than means we're going to shade the area to the left. Right, less than is always going to be the left, greater than is always going to be to the right. Right, so if we compare these 3 pictures that we have 3 different cases here. Right, we have a case for greater than, we have a case for in between, and we have a case for less than. If you look back at the previous page of your notes, right, when we get to step 3, right, we have 3 different types of problems that we can run into. We can have a less than, we can have a between, or we can have a greater than. Right, so that's why it's so important to draw these pictures first before we start, so that way we know what our procedure is going to be as we continue to work through these problems. All right, so let's talk a little bit more about this third step. Right? And this will also give us a brief introduction to our table as well. Right? So what we're going to be using is we're using something called our standard normal model. Right? So we've already used the term normal model because as we're going through, it is a normal curve. But our standard normal model, the word standard comes from a mean of 0 and a standard deviation of 1. What this means is our standard normal model perfectly matches up with our, what we kind of think of as our general picture for our empirical rule, right? Where we're moving to the left and right and we're using the standard deviation of exactly 1. In order to use our standard normal model, then we need standard units. So this is going to tie into our z-scores and that formula that we saw, again, back from chapter 3 as well. Again, we're slightly changing our notation because we're using our mu and sigma instead of x bar and s. But standard units, standard normal model, z-scores, all of these things, all of these words tied together. The table that we're going to use, our standard normal curve cumulative probabilities, it's in the back appendix of your textbook. It's on page A2 to A3. I have a PDF file that I will make sure is uploaded on Moodle, so that way if you do want to use that if you want to print one off and use it as you're going through your homework, you will be able to do that as well. Right. So looking at the table, right, so I'm going to slide down here and kind of focusing on the bottom part of the page now. Right. When we're reading the table, the numbers in the left margin along with the numbers up top represent our z-scores. As we are thinking about our z-scores, we're always going to be rounded to 2 decimal values. So if we look at this particular table, the circled number in here is going to represent a z-score of 1.00. Because if we go down this left column, we see 1.0. So that's always going to give us the whole number and then our first decimal. And then if we look up along the top here, notice that our first decimal is always 0. So we don't care about that 0 part, we just care about the part that's in the hundredths place. So this circled number here, this 0.8413, is 1.00. If we move to the number to the right, this 0.8438, well, that's 1.01. The next one would be 1.02, and so on and so forth. As you are looking at your table, generally speaking, if it's one that I have printed out and I give to you guys to work on in class, positive numbers are always on one side, negative numbers for your z-scores are always on the other side. So it is kind of a matter, and same thing in the appendix in your textbook, it's going to be flipping back and forth between the 2 pages based on if you have positive z-scores or negative z-scores. So signs do matter, making sure you get your things into your z-score formula correctly does matter. Rounding to the nearest hundredth place correctly does matter as well. All right, so let's talk through one of the examples that we sketched a little picture of. Right. So again, I'm going to go through the sketches individually one more time, even though we've already done them, just to kind of refresh and make sure that we know where all of these pictures come from, and then we'll go through this entire procedure. So using the normal model N64,3, suppose we were to select an adult woman from the United States at random and record her height. What is the probability of randomly selecting a woman less than 62 inches tall? So again, the first thing we're going to do when we draw our picture, right, is we're going to label our values along our normal curve. So again, the first number after the N, that's our mean. So in this case, our mean is 64. And then as we move to the left, we add 3 each time. So 64 plus 3 is 67, plus 3 is 70, plus 3 is 73. And then as we move this way, we subtract. 64 minus 3 is 61, minus 3 is 58, minus 3 is 55. All right, then in this first one, we are asked, what is the probability of randomly selecting a woman less than 62 inches tall? All right. So 62 was right about here, and less than 62 means we want to shade this area over here to the left. So our first step is always, always, always to draw a picture. Right. Our second step then is to find our z-score. As we're finding our z-score, we are using our formula. Again, our formula looks slightly different, but it's still very, very similar to what we saw back in chapter 3. The first thing in here is our observed value. So in this case, it's the number that we're being asked about. We're being asked about 62. So up top, 62 is our first number that's going to go here. Okay. Then we're going to subtract our mean. So our mean is 64, and then we're going to divide it by our standard deviation. Our standard deviation was 3. Okay. So 62 minus 64 gives us -2 over 3, okay, which we always want to change these to decimals. We want to round them to 2 decimal values. We want to round them to the second hundredths place. This is going to give us -0.67. Okay. So our first and second step shouldn't feel that new, right? Because we did stuff like this back in chapter 3. Right? When we get to the next step, though, that's where the new part for chapter 6 comes in. So down at the bottom here, I have a picture of this table. And what we're going to do is we're going to find our -0.67 in our table. So my row here is a little bit off, so I'm going to, it's not actually going to be what's circled here because when I reprinted this it didn't print correctly, but we're going to move this up a little here. We're going to find our z-score using our headings. So we're going to go down here and we're going to go all the way down until we see -0.6, and then from here we're going to move to the right until we hit the 0.7. The one that is posted in Moodle, the complete solutions, the row and box do match up correctly. It's just not on this particular sheet that I have. So again, we find our -0.6, we go over, and what we should see then is this -0.2514. Right? So we go on our row of -0.6, go till our second decimal is 7, and we have that value there. So what we have using our z-score of -0.67, our area to the left of z equals 0.2514. Once you get used to using this table, it's not too bad. Again, based on whether your z-score is positive or negative, that's going to help you determine which side of the paper that you want to look at. Right? So do you want to look at the z-score that's positive? Do you want to look at a z-score that's negative? Again, when you're plugging them into your formula up here, it is absolutely essential you get them in the correct order. That way you end up with the correct sign. Okay, now that we found our value in the table, we need to decide, looking at our picture, well, do we have the correct area or do we need to do some sort of subtraction with it? So looking at our table, our area to the left of z is 0.2514. If we look in our picture, we do have the area to the left. Right? So if we are dealing with a less than case, right, and we're looking at this piece here, this number out of the table is simply our answer. Right? So this number out of the table is simply our answer. So our area to the left of z, right, is 0.2514. So we're going to say the probability of randomly selecting a woman less than 62 inches tall is about, and if we look at this 0.2514 and we think about it as a percent, we're going to say is about 25%. So since we were dealing with a less than means an area to the left. On the next page, we're going to talk about our two other types. We're going to talk about a between and a greater than. And then after we get through those, we'll go through and work through some more. Just kind of reviewing all this, talking about how to use the table and everything along those lines. All right, so we're still using the same model. So we're talking about women's heights. Our mean is 64 and our standard deviation is 3. So we're going to continue to label this as we have with the previous pictures. Okay. In this case, again, we're looking for a between. Okay. So we're going to put our 62 in our picture. We're going to put a line for 67 in our picture. And then we're going to shade appropriately. Right, between, so we're going to shade the area in the middle. Right, since we have two values this time we're going to need two different z-scores. Right, so let's do our 62 first. So we're going to do 62 minus 64 over 3. That's our negative 2 over 3 that we just had, which is negative 0.67. Then we're going to use our other height. Our height is 67. 67 minus 64 over 3. Right. That's going to give us 3 over 3, which turns out to be exactly 1. So it's 1.00. Okay. All right. So we're going to look these values up in our table. The first value that we just found, we just used in the last problem. So to start with, our area to the left of our first one, so if z, we'll do this way, negative 0.67, our area to the left of z is at 0.2514 that we just looked at. For our z equal to 1.00, right, on one of the other previous pages, right, we had a z-score of 1.00, right, and the number in our table was 0.8413. So our area to the left of this z is 0.8413. Now to finish this off, again, we're thinking area between. So anytime we have an area between, right, we're looking for just this portion here. So we're going to take our larger number, right, our larger area, and we're going to subtract our smaller area. So we're going to go 0.8413 minus 0.2514, and that gives us 0.5899. So area between is always a subtraction. And it's always a subtraction where we're taking the larger number minus our smaller number. Because we're taking the whole area to the left of that larger one, and then we're getting rid of this little portion, which is just leaving us the part in the middle. So the probability of randomly selecting a woman between 62 and 67 inches tall is about 59%. All right, so area between is always a subtraction problem. Right? So we take our large number, so in this case our larger area, our larger percentage, right, 0.8413, we subtract our smaller percentage, right? And then we can, again, as you're doing your homework in my math lab, round accordingly. For the most part, it's maybe a percent or fraction or decimal of a percent, but it'll specifically tell you how many place values to round your final answer to. Our z-scores, as we're working through the problem, should always have 2 decimals. All right, so let's do one more. So in this case, we're using our same normal model. So 64, 67, 70, 73, 61, 58, 55. This time we're asked for a woman taller than 62 inches. Okay, so we're going to put our 62 in here. Taller than means we're going to shade our area to the right. All right, so our z-score, 62 minus 64 over 3. Right, that's our same negative 0.67 that we keep getting. Right. So our area to the left of that z is that same 0.2514 that we had. Now in this case, the area to the left is the space that is left blank in our picture here. Right? We don't want that area. We want the part that's on the other side of it. Right? And if we think about this, our area to the left and our area to the right are complements of one another. They should add up to 100% total. So to find this one, our area to the right, we are going to find by taking 1 minus our area to the left. Right? Same as taking 100% minus our about 25%. Right? So that's going to give us 0.7486. So the probability of randomly selecting a woman taller than 62 inches is about 75%. So again, it is a complement of shorter. Right? 25% chance being shorter, 75% chance being larger. Again, I didn't look up the z-score in this particular case because we've already used it in our last 2 previous problems. As we continue to go through a couple more examples, we will talk a little bit more about looking those z-scores up in the table. For now, I'm going to stop this video and then we will continue on with some more examples in section 6.2 in the next video.